Good morning. Good morning. Can you hear me? Right. Good. Okay. We discussed up to physical state changes, right? Physical state changes. How many physical state changes we discussed? Physical state changes. How many physical state changes? Six. No. Physical state three. Physical state changes six with me. Physical state changes six types. Give me a second. Yeah. Physical state three. That's been solid, liquids, and gases. Solid, liquids, and gas. Okay, solids convert into liquid. What's the name? Solid convert into liquids. What's the name? Solid convert into liquid. It is melting. Good. Melting. Melting. Now liquids convert into gas. Liquid convert into gas. That is not evaporation. You know, it is not evaporation. I need liquid convert into gas at boiling point. Evaporation is another thing. Evaporation means liquids convert into gas less than boiling point temperature. As example, water convert into water vapor less than 100 Celsius. 100 Celsius is a boiling point of water, right? Vaporization. Vaporization. Yes, no. Vaporization. Now opposite, liquids convert into solids. Liquid convert into solid. Freezing. 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 Gas again convert into liquid. The clouds are forming due to this physical state change. Gas, water vapors convert into liquid. The precipitation, the rain is formed due to this condensation. Gases, water vapor convert into water again. Condensation. 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 Okay, solids without flow into gas liquid state directly convert into gas. Solids directly convert into gas. What is this physical state change? Solids directly convert into gas state without liquid state. It is sublimation. 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 Gases directly convert into solid without liquid state. It's a direct path. Deposition or reverse sublimation. Deposition. Deposition. Okay, now you have idea what's the meaning of physical state change. Physical state change means there are three main types of physical state of any matter: solids, liquid, and gases. Physical state change means physical state change from one physical state to another physical state. right? Solid convert into liquid, ice convert into water, water convert into water vapor, water vapor again convert into water, water convert into ice. Okay, they are the physical state change. Okay, if you got this melting, think about melting. Ice convert into water. Is it heat absorbing process or heat releasing process? Melting. You yeah, heat absorbing, right? That means if you got ice cube, මෙහෙම ice cube එකක් ගත්තොත්, think it is ice cube. Normally its temperature -5, approximate -5, but environment temperature 30 or 25 Celsius. Then heat always transfer high temperature to low temperature. Then it is heat absorbing for melt, right? For convert into water, it's heat absorbing. Therefore, this melting, vaporization, and sublimation all are heat absorbing process, heat absorbing physical state changes, not chemical changes, not chemical reactions. Chemical reactions we discuss in next lesson, thermochemistry lesson, right? Melting, vaporization, vaporization, sublimation, they all are endothermic. Melting, vaporization, sublimation, these three processes are endothermic process. Endothermic means heat absorbing. Heat energy absorbed for convert the physical state change. If you got freezing mean what? Liquid. That means water convert into ice. Water convert into ice. Is it exothermic or endothermic? Is it heat absorbing or releasing? This is a water cup now. Think this is a water cup. We need to place in a refrigerator, right? Normally refrigerator temperature -80. Now it is 30 Celsius. Now what happened? Heat absorb or release? Heat releasing. No, heat releasing for freezing. Therefore, freezing, condensation, deposition physical state changes we called as exothermic physical state changes. Exothermic, मेला heat release करना. They are exothermic. They are endothermic. Right? Understood? Exothermic physical state changes and endothermic physical state changes. Exothermic physical state changes and endothermic physical state changes. Okay. Are you okay up to now? We discussed only this point, right? Humid. Okay. Now, what's the meaning of physical state change? The physical state of any matter convert from one physical state to another physical state. Very simple. One physical state to another physical state. There are three main physical state of any matter: solid, liquid, and gas. There are 6 different physical state changes: melting, freezing, condensation, vaporization, sublimation, deposition. Right? 6 physical state changes. Now we have to understand how it is converting. Now you know, maybe that. Now this is the most interesting lesson, interesting part of the lesson. In O level, you're doing up to this level, right? Heat capacity, specific heat capacity, and physical state change. Okay, now you have to understand how it is. Now think ice cube. Ice cube. If you got ice cube, it is H2O solid state, right? H2O solid. H2O solid state. Okay, physical state change mean ice convert into water. That's a melting. That's a melting, right? Then ice convert into water mean H2O liquid. Is there any physical state change? Is there any physical state change? No. H2O, H2O. Sorry, there is a physical state change, there is no any chemical change. Sorry. Is there any chemical change? No. H2O, H2O. But physical state difference. Physical state difference. That's why I told it is not, there is no any chemical change during physical state changes. Right? Ice mean H2O, water solid state. Water mean water liquid state, right? But what is the difference? Physical state only difference. Physical state mean in molecular level what is the difference? What are the difference between H2O solid and H2O liquids? In molecular level, now you already know. What are the differences? If you got solids, their molecules are highly compacted, right? Highly compacted, right? Highly compacted. Molecules highly compacted. Like this. Molecules highly compacted and very strong intermolecule bonds. What else? Their vibration is very limited and very limited spaces between molecules, right? Spaces are doing, and their molecule kinetic energy very low, right? They are the solid state characteristics. Remember, I already explained in the first second day, I think. Page number 2. I have given all differences, right? But if you got water state, water mean liquid state, the same molecule mechanism, but small differences. The liquid state also made by molecule. And how about molecule structure? They are not compacted like this, right? They are not compacted like solid, but they closely pack. No very strong intermolecule bonds, moderate level intermolecule bonds like this. And the spaces medium level, now they have spaces into medium level, and they have vibration ability, they have kinetic energy, molecules has kinetic energy. Yeah. Then how to convert this compacted molecule structure into this liquid medium level compacted structure? How this change? Can anyone explain? How now? If we keep ice cube in outside, it's absorbing heat, right? Heat continuously absorbing. Heat absorb bela kohomada meka convert වෙන්නේ? How it is convert? How it is converted? Any idea? You meant how it is converting? The main thing, absorbing heat, right? Met me any idea? No, I don't need the full story. Can anyone send me a keyword? How it is convert? Q&A? Okay, actually, no, it is me expansion limit. Heat absorb and increase the space between molecules. It is expansion. Now solid objects absorb heat and increase their vibration and kinetic energy, then increase their spaces, molecule spaces, then increase in size. That is expansion. That is not a physical state change. Yeah, tikak hari, but it is expansion. Think how it is converted. Now solid mean highly compacted molecules. Liquids mean averagely medium level compacted molecule structure. How it is convert? Solid ice cube convert into water. How it is changed the molecule structure? How it is changed the molecule structure? Remember now. That's the most important part, right? it is just like a story, right? Don't need to by heart, just understand, that's enough, right? Remember, now if you got solid, okay, easy understand. Let's take liquid, right? Liquid convert into gas. Liquid convert into gas. Liquid convert into gas mean what happened? Water liquid convert into water vapor. That one also physical state change, right? Water vapor. Water vapor mean water vapor. Water vapor mean H2O, same chemical structure, H2O, same chemical structure, gases, only physical state change. What happened in molecule structure? Very weak intermolecule bonds, and like this, molecules are freely moving. Molecules freely moving. Very low intermolecule bonds. Very weak intermolecule bonds. Then it is converted to liquid state to gas state. Right? Hari. Adbalamu. For easy understand, then you can understand solid liquid story. First, let's try to understand how to liquid convert into gas. Water convert into water vapor. What's the story? Hari. Remember? Now, if you got liquid, how about their molecule structure? They are moderately compacted and medium level spaces, and they are closely compacted, right? Think it is water. Now think it is water sample. Water sample, right? Water. Now if it is heated continuously heating, right? Continuously heating. If it is heated in constant rate, එකම rate එකකින් heat කරගෙන යනවා. Then if you observe by a thermometer, we can see the temperature is increasing, right? Temperature increasing mean what? In the first day I explained. Temperature increasing mean of any substance, the molecule kinetic energy increasing, right? Molecule kinetic energy, that means that's a water liquid state molecule structure. When increase in the temperature, molecule kinetic energy increasing, right? Increasing molecule kinetic energy, that means vibration increasing and increasing volume, that means it's the liquid start to expand, right? That we call as thermal expansion, liquid expansion, right? That we call as liquid expansion. But when it now think it is 30 Celsius, 30 Celsius, and if it is continue increase up to 100 Celsius in constant rate, we increase the temperature up to 100 Celsius. 100 Celsius. You know, 100 Celsius is a special temperature for water. Why? The 100 Celsius is a boiling point of water, right? Boiling point of water. This is a boiling point of water. Boiling point of water. Boiling point mean, remember, that's the most important point. Boiling point is this liquid molecules, they reach to maximum vibration, maximum molecule kinetic energy with this intermolecule bonds. එකන මේ intermolecule bonds එක they reach to maximum intermolecule bonds, maximum vibration with these intermolecule bonds. Now intermolecule bonds mean they have some barrier, they have some bonds. මෙයාලා එකට bond එකක් තියෙනවා. With these bonds they can't unlimitedly vibrate. They have a limitation, they have a limit. This boiling point mean with this intermolecule bond, this is a maximum vibration, maximum expansion, actually maximum physical may increase in the space, right? I got when it is increase in the temperature, that means when we provide heat, this heat energy absorbed by molecules, then increase their kinetic energy. When it is reached to a certain level, certain temperature, 100 means it's for water, for other liquid it is different values. When it is reached to a certain level, certain temperature, what happened? This molecule kinetic energy, molecule vibration reach to maximum level with their intermolecule bonds. Understood? Understood up to now? හරි. එයාලා reach වෙනවා maximum level එකට. That's a maximum. ඒ කියන්නේ with this intermolecule bonds තව වැඩි වෙන්න බෑ. That's a barrier, that's a limitation, that's a limit. They have barrier, they have bond. Due to this bond, as liquid state cannot increase the intermolecule space එක වැඩි කරගන්න බෑ. Right? Then what they doing, this is 30 Celsius water, right? 30 Celsius water, it is 100 Celsius water. 100 Celsius water. What they doing? They utilize some heat amount. Now we provide heat in constant rate. They utilize some heat amount, heat energy, and try to break down these bonds. Break down this part of their bonds. They try to break down their bonds. That we called as a physical state change. That's we call as a physical state change. Then it is converted to 100 Celsius. At this physical state changing stage, at this bond breakdown state, we can see the temperature is constant because the provided heat utilized for bond breakdown process. याला use करने bond एक breakdown करा, right? Utilized for bond breakdown process. Okay, this provided heat energy utilized for bond breakdown process, not for temperature increase, not for increase kinetic energy. Temperature increasing means kinetic energy increase. That's a story I already explained firstly. The temperature mean average measurement of molecule kinetic energy, right? Then if it is temperature increase, need to be increase the molecule kinetic energy. You can temperature එක වැඩි වෙන්න molecule kinetic energy වැඩි වෙන්න ඕනේ. But at this specific temperature, certain value method ආවට පස්සේ at boiling point, what they doing, they utilize some part of heat එකක් use කරලා they try to break down their bonds. As a result of break down their bonds, it is convert 100 Celsius water vapor gas state. Now they already break down their bonds, right? That's why it is convert to this type molecular structure, break down in their bonds. Understood? Now after converting to 100 Celsius water, 100 Celsius water vapor, now it is physical state is completed. In physical state, in the moment of physical state, remember there is no any temperature change. Now in temperature change, the same temperature, 100 Celsius water converted to 100 Celsius water vapor. Why don't have physical state? Why don't have temperature difference? Temperature difference එකක් නැත්තේ? Because the provided heat utilized for bond breakdown process. එයාලා heat එක use කරන්නේ bond එක breakdown කරා. Not for increased molecule kinetic energy. Right? Then what happened again? If it is complete the physical state change, now we can increase their kinetic energy. ඊට පස්සේ ඒක වැඩි වෙන්න පුළුවන්. Up to any level, 150 Celsius vapor or whatever. Any temperature. After physical state change, they have ability to increase the kinetic energy. Understood? Okay. Now I will explain for solid, how to solid convert into liquid, the same story. Now solid mean think ice cube. Think ice cube. Ice cube. Ice cube. Think it is ice cube, right? Now think it is minus 5 Celsius. Initially minus 5 Celsius ice. Minus 5 Celsius ice cube. Okay, now if it is keep in outside, now it is heated in constant rate. Heat absorb karna in constant rate. Then what happened? Minus 5 Celsius ice convert into 0 Celsius ice. 0 Celsius ice. When it is increasing the temperature, what happened? The kinetic energy, the molecule kinetic energy increasing, and at 0 Celsius it is reached to maximum level. Now you know ice mean they are highly compacted. Loku bond ekak තියෙන්නේ. And they are highly compacted, right? With this highly compacted molecule structure, with when we heating, they absorb this heat and increase their kinetic energy. When it is converted into 0, it is reached to the maximum kinetic energy with this compacted bonds, highly strong intermolecular bonds. They reach to maximum intermolecular kinetic energy, right? They reach to maximum kinetic energy at 0 Celsius. Why? Absorb heat energy and increase their vibration. And at 0 Celsius, they reach to maximum, right? 0 Celsius maximum. At this temperature, what happened? Now it is reached to maximum temperature, maximum vibration, maximum vibration. At this temperature, but continuously heat absorbing, right? Continuously heat absorbing. Then what they doing? These molecules utilize some part of heat, Now this is a solid. Solid mean they are highly compacted. Solids mean highly compacted. Highly compacted like this. Now they have very strong intermolecular bonds. Very strong intermolecular bonds. Solids. Like this. Very strong intermolecular bonds. Now the same story. At 0 Celsius, these intermolecular kinetic energy, molecule kinetic energy reach to the maximum at 0 Celsius. Heat energy absorb and increase up to maximum. At 0 Celsius, what they doing? These molecules absorb heat and break down their part of bonds. Only half, 50% वगे break करना, right? Break down their part of bonds. That's why it is converted to liquid state. Liquid state. Now you can, I told you at physical state changing movement. At physical state changing movement, there is no any temperature change because the absorbed heat utilized for bond breakdown process. That's the main thing you need to remember. Absorb heat utilized for may absorb karna heat එක use කරන්නේ මොකටද? For bond breakdown process, not for increased kinetic energy. Therefore, there is no any temperature difference. 0 Celsius water vena. This is a melting. This is a melting. If it is converted into water, now it is already bond breakdown now. Part of bond breakdown, now it is liquid state. Now we can increase it. If we provide heat continuously, it's increase their kinetic energy and convert into 30 Celsius, 40 Celsius water, no problem. If we continue, it is converted to 100 Celsius water, again vaporizing. Vaporizing means the methana තියෙනවා කරනවා 50% bond. This 50% bond also break down and then it is converted to freely moving molecules. That's the liquid state, sorry, vapor state, gas state, right? Understood? Okay, this is a physical state change story. Now you can see any physical state change. The thing is, if you got endothermic process, exothermic I will explain later. Endothermic process, that means melting, vaporization, sublimation process, what happened? They absorb heat and in a certain temperature, they try to break down their bonds. They break down in their bonds. As a result of break down their bonds, what happened? At this moment, some amount of heat energy absorbing, right? But there is no any physical temperature change. Physical state changing, you can see same temperature. Same temperature. 0 Celsius ice convert into 0 Celsius water. In the movement of physical state change, there is no physical state change. Sorry, in the movement of physical state change, there is no any temperature difference. In the movement of physical state change, there is no any temperature difference. That's the thing you will have to understand. Then any physical state change, no any temperature difference. Why? Now you already know exothermic process. When it is reached to maximum kinetic energy, they utilize heat energy for bond breakdown process. A heat energy use karane bond breakdown karan. They not increase in the kinetic energy. That's why same temperature. Okay. Yes. Now, if you got the exothermic process, become freezing. Freezing, what happened? Freezing. Now it is ice cube. Sorry, water. Water. Liquid state. Now it is liquid state. Liquid water. Convert into solid water, that means ice. Solid water, that means highly compacted state. Okay, how it is convert? Now the same story. Now think it is 30 Celsius water. If you got 30 Celsius water, now they have some kinetic energy, right? They have some kinetic energy. Now, if it is cooled down, what happened? Their molecule heat energy releasing. Now heat energy releasing from molecules, then molecule kinetic energy decreasing. These molecules try to compact to each other, right? Molecule kinetic energy decreasing. The opposite way now. Heat releasing, exothermic, right? Heat releasing, and it's converted into 0 Celsius water. 0 Celsius is a special temperature of water. Why? It is a freezing point. Melting point as well as it is freezing point. Freezing point at 0 Celsius. Then at 0 Celsius, they reach to minimum. Now it is highly compacted. It's just highly compacted. Then what happened at 0 Celsius? They removing some heat of this, releasing some heat of energy, heat energy, and it is converted into it's forming new bonds between molecules. They're producing new bonds between molecules because they have very low kinetic energy. Therefore, they again producing bonds. They again making new bonds between molecules. At this state, 0 Celsius water converted into 0 Celsius ice. That means solid state. I got? Okay, that's a physical state change in exothermic process. Exothermic physical state change. Heat releasing. In endothermic physical state change, heat absorbing and break down their bonds. In exothermic physical state change, heat releasing and producing new bonds. They making new bonds between molecules. Okay, that's the story. Understood? You met? Clear? Okay, let's move into tube. Okay, now actually you don't need remember this full story. If you have a brief idea, that enough. Okay, actually our topic is latent heat. I will revise what we doing now. අපි මොනවද මේ කරන්නේ? We doing quantity of heat, no? We doing quantity of heat නේ. Quantity of heat. Quantity of heat. What's the meaning of quantity of heat? Capital Q. What's the meaning of quantity of heat? Quantity of heat means the amount of heat absorbed or released by whatever object or system, right? The amount of heat absorbed or released. The amount of heat absorbed or released by any system or object we called as quantity of heat. Hari. Now, we have three main methods to calculate the quantity of heat. What's the first one? Heat capacity. Heat capacity method. Using heat capacity method, capital C. The second one is a specific heat capacity method. Specific heat capacity method. Specific heat capacity method, simple C. Okay, last week we already discussed heat capacity and specific heat capacity already. Now, today our main topic is specific latent heat. Specific latent heat is a topic. Specific latent heat. Right? Specific latent heat means capital L. Right? Now, what's the story? The lesson, the second part of the heat lesson, the main topic is quantity of heat. The quantity of heat mean what? The amount of heat absorbed or released by system or object. The amount of heat absorbed or released, that means quantity, right? There are three methods to calculate quantity of heat. What are the methods? Heat capacity, specific heat capacity, and specific latent heat. Now, heat capacity and specific heat capacity already discussed, right? Heat capacity means Q equal C theta. Specific heat capacity means Q equal MC theta. Up to now we already discussed. But our next special part is the specific latent heat. Specific latent heat, capital L. ඒක කරන්න තමයි මෙච්චර මේ දුර ආවේ. හරිද? We discussed physical state changes. What's the meaning of physical state change? One physical state change from one state to another state. We discussed 6 physical state changes, right? 6 physical state changes: melting, freezing, vaporization, condensation, sublimation, and deposition. Right? I told any physical state change, what happens if it is exothermic process? If it is exothermic physical state change, if it is endothermic physical state change, melting, vaporization, sublimation, what happened? They absorbing heat and come to their maximum kinetic energy at a certain temperature, right? When it is come to maximum kinetic energy, they using part of heat, they break down in their bonds and convert it to next physical state, right? Break down in their bonds. If you got wait, give me, I will explain. Now, if you got exothermic heat releasing, then kinetic energy decreasing, molecule compacting, right? Molecule compacting up in a certain temperature, they maximum compacted, then they producing new bonds between, releasing some part of heat, they making new bonds between molecule. That's the exothermic physical state change. Yeah, good question. Sublimation. How to convert sublimation? Sublimation is a special process, special physical state change. Now, solids directly convert into gas. Now, how about solid? They have highly compacted, right? Solid molecules highly compacted. Solids highly compacted. Now, when it is heated, what happened? This molecule kinetic energy increasing, right? Heat energy absorbed and molecule kinetic energy increasing. Now, at a certain level, they reach to maximum kinetic energy. they reach to maximum kinetic energy at a certain level. At a certain level, they reach to maximum kinetic energy. Then that's a special case. These specific compounds, that specific substance, they break down in their all bonds, completely break down their bonds. At this state, are 100% में bond breakdown करना. Therefore, directly they convert into freely available molecule, gas state. Solid directly convert into gas state. That one also same story. At a certain level, they utilize some heat of energy and break down their bonds, but in sublimation process break down 100%. ඔක්කොම bond ටික break down කරනවා, but water and the regular method not like that. They break down 50% bonds and convert into liquid state. In the vaporization process, convert the break down the remain bonds. Understood? This is special. අපි ගත්තාම water, ethanol like substance not going this path. They convert into liquid and convert into vapor. Regular path. Iodine, sodium, magnesium type special substance only going this path. Sublimation. Understood, Yumit? Hi. Okay, do you have any doubt up to now, Yuvani, Nabil? Because next part is very important to understand. Next part, this part very important. Nabil? Dulain? Hi. Now, okay, now write down a topic in your short note. In your short note, molecular level. What is the final topic? Read it in short note. Physical state change only, right? Triangle එක විතරයි නේද? Yes. Then write down molecular level changes. Molecule level changes in physical state change. Physical state change. In a physical state change. Molecular level changes in physical state change. First one, first subtopic, exothermic physical state change. Exothermic physical state change you already know in the triangle. Sorry, endothermic, sorry. Endothermic physical state change. Endothermic means melting, sublimation and vaporization. Endothermic physical state change. Okay, first step, I'm going to write a flow chart for easy remember. මේවා මතක තියා මේවා අහන්න exam එකේ මම for understand next part, the latent heat part, you need this part. That's why I explained, right? Now think it is short note. it's a solid. අපි ගමු -5 Celsius solid. That means ice part, ice -5 Celsius. -5 Celsius solid, now heated. 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 Then it is converted into 0 Celsius. 0 Celsius solid. 0 Celsius solid still ice cube. That's a melting point. Melting point. Melting point. At this time, what happened? Increase kinetic energy. Increase heat energy absorb heat energy and increase the kinetic energy. Ke mean kinetic energy. Hurry. May increasing process 0 Celsius with. That's the melting point. At melting point, that is a maximum molecule kinetic energy. Kinetic energy with strong intermolecule bonds. With strong intermolecule bonds. IMB mean intermolecule bonds, right? That's a maximum. The melting point is a maximum intermolecule bonds. Maximum kinetic energy with strong intermolecule bonds. Say bonds nisa when pula maximum vibration එක වෙලා තියෙන්නේ at melting point එකේ. Right? Now it's converted into 0 Celsius liquid. Zero Celsius liquid, that means water. Now water. Still ice. Maybe with ice. Only one theory. Now this process is a melting. Now this is a melting. Now this is a melting. In this state, what happened? Absorb heat energy and break down part of molecule bonds. Okay. Part of molecule bonds. That's the melting. Okay, you have to remember this heat energy not involved for increased kinetic energy. That's why in the melting state, there is no temperature difference, right? In the change එක වෙන වෙලාවෙදී heat energy use කරන්නේ වෙන process එකකට. The absorb heat energy utilized for another process. That's why the temperature same. The temperature is same. Okay, that's the physical state change, molecular level structure, molecular level story of endothermic physical state change. Right. Absorb heat energy and break down part of molecule bonds. Complete. Okay. Okay, I gave you only melting. The vaporization also same story. Have make then liquids kinetic energy increasing, heat energy absorbed and kinetic energy increasing, then temperature increase up to boiling point. Then at the boiling point with this 50% molecule bonds with their available liquid molecule bonds, they reach to maximum at boiling point. Then again breakdown bond. This bond breakdown in process is a vaporization. හරිනේද? මම එකක් දුන්නේ to remember the process. Okay, you meant complete? Finger? Complete with me? You and okay. Write down අපි ලියමු exothermic එකකුත් the same story but let's note down second topic endothermic exothermic physical state change. Exothermic physical state change. Exothermic physical state change. Exothermic physical state change. Now it is minus 5 sorry 5 Celsius water liquid. Water. It's converting to 0 Celsius liquids. That means water, still water. At this level, release in the cooling process, release heat energy and decrease the kinetic energy. Decrease the kinetic energy. This is the freezing point. 0 Celsius for water, it is a freezing point. Freezing point. Freezing point. Freezing point means there is the minimum molecule kinetic energy. Kinetic energy as liquid. As a liquid. That's a minimum because now molecules already compacted. Right? Now it is convert it to 0 Celsius ice. That means solid. 0 Celsius solids. That means ice. This process we called as freezing. Freezing. In this process, release heat energy and making new bonds between molecules. They're making new bonds between molecules. That's why it is converted to solid state. Solid state. Okay, that's the freezing. That's the freezing. In the bond formation stage, there is no any temperature difference because release heat utilized for this bond formation process. No kinetic energy change, right? No kinetic energy change. Therefore, no temperature difference in any physical state change. No temperature difference in any physical state change. Hari. Betul ya? Is heated. No, not heated. Sorry, cooling. Okay, Sumit, complete quickly. Afsal, complete. The same story, na? Opposite way. Met me. That means same thing met me. This is for exothermic physical state change. Exothermic physical state mean now it's a liquid. 5 Celsius any temperature, right? Any temperature liquid. Api itam water here. Think it is water. Now it is cooling. In the cooling process, release heat energy and decrease the kinetic energy. Molecule kinetic energy decreasing. That means molecules compact. then it is converted into 0 Celsius liquid. 0 is the freezing point. That's for water, right? For other liquid that can be in another temperatures, right? Now, freezing point. The freezing point mean this is a minimum molecule kinetic energy as liquid state. Minimum molecule kinetic energy as liquid state. Liquid state. Right? Minimum molecule kinetic energy. They reach to minimum level now. That's a minimum. It can compact right? Molecules already compacted as liquid state. Now, what happened? They releasing another amount of heat, releasing the amount of heat and making new bonds. Now they already compacted. They're making new bonds between molecules. They're making new bonds between molecules. That's why we call exothermic. In the physical state change, heat is releasing, right? Heat releasing heat, and they're making new bonds between liquid molecules. That's why they convert highly compact solid state. Now it is ice solid state. No any temperature change. No any temperature change. Okay. Okay, you want complete and understood? Okay. Now actually that's not required. That is our me. This is a lesson actually. Write down the next topic, the latent heat. We got 1 hour time to understand physical state changes to understand the latent heat, right? Latent heat. Next topic, the latent heat. Next main topic, the latent heat. Latent heat. Latent heat. Latent heat. Latent heat, write down within bracket, hidden heat. Hidden heat. Hidden heat. Why we call latent heat as hidden heat? අපි hidden කියන්නේ මොකද්ද? සැඟවුණු තාපය. Hidden heat. Hidden heat. Hidden heat. Now what's the meaning of latent? Latent means hidden. Now what's the meaning of hidden heat? Now we already know hidden heat. Can anyone explain? Latent or hidden heat. Okay, latent or hidden heat mean in a physical state change, if it is endothermic physical state change, we can make a solid convert into liquid, right? Solid convert into liquid. Ice is example, convert into water. Now I told the ice melting point is 0, then 0 Celsius ice convert into 0 Celsius liquid. 0 Celsius ice convert into 0 Celsius liquid. Now I told in this change the physical state, some amount of heat absorbing, right? Some amount of heat absorbing. Q එකක්. Some amount of heat, quantity of heat absorbing for what? For their bone breakdown process. But is there any temperature difference? No any temperature difference. That's why in the physical state change, the amount of heat absorbed without any temperature difference, that we called as the latent heat. That we called as latent heat. It's not only for melting, any physical state change, it's absorbing some amount of heat for bone breakdown or bone making process without any temperature difference. That's one we called as latent heat. It is not specific latent heat, right? Hidden, සැඟවුණු heat එක. Hidden heat means the amount of heat absorbed or released during a physical state change without any temperature difference. Understood? Then තේරෙනවා. The okay, write down. Latent heat is a topic. Write down its star mark. The amount of heat, the amount of heat absorbed or the amount of heat absorbed or release, absorb or release during a physical state change, during a physical state change, during a physical state change without any temperature difference, without any temperature difference is called as the latent heat, is called as the latent heat, is called as the latent heat. Okay, in a physical state, don't write, in a physical state change some amount of heat, if it is endothermic එකක් නම් it's absorbing heat, if it is exothermic one, releasing heat without temperature change, without temperature change for bond breakdown or bond making process, that we called as, this amount of heat we called as a latent heat. Met me? Understood? Nabil? Now the latent heat is done. Latent heat means the amount of heat absorbed or released during a physical state change without any temperature difference. You know why temperature, no in temperature difference? Because the absorb or release heat utilized for bond breakdown or bond making process, right? Therefore, no kinetic energy change. Due to that, no any temperature difference. Now you already know the full story of physical state change. Now, what is the actual topic? This is not our actual topic. What is our actual topic? Specific latent heat. Now you can write down your third main topic. Third main topic means quantity of heat. First one, heat capacity. Second one, specific heat capacity. This is the third one. The make a current that's a target. Specific latent heat now. Specific latent heat. Specific latent heat. Specific latent heat is a capital L, not latent heat. Specific latent heat is a capital L. Remember, specific latent heat is a capital L. Specific latent heat is a capital L. Latent heat වලට symbol එකක් නැහැ, no symbol for latent heat. Latent heat means just amount, heat amount in a physical state change without temperature change. හරි. Now, in our syllabus, specific latent heat explained for two main physical state changes. The first one, melting. Melting. We can explain for anyone. හරි මම දෙකක් කියලා දෙනවා. එතකොට මේකම apply කරගන්න තියෙන්නේ. Same thing you can apply for other physical state change. Melting. හරි. Now what is the meaning of latent heat? You already know. What's the meaning of specific? Specific. අපි heat capacity and specific heat capacity discuss. එතකොට what's the meaning of specific? What's the meaning of specific? Jumet. Specific. What's the difference between heat capacity and specific heat capacity? Then you can understand what's the meaning of specific. No, specific mean unit mass of substance. Yeah, correct. Temperature no required. You mean temperature increase by 1 degree. It is coming from heat capacity also. Heat capacity increase the temperature by 1 degree. Specific heat capacity mean increase. Yeah. Yes. Heat capacity mean increase the temperature by what? The heat requirement, the amount of heat requirement increase the temperature by 1 degree of any substance, any object. Heat capacity. Specific heat capacity mean the amount of heat requirement to increase the temperature by 1 degree of unit mass. Then specific unit mass word. That means we only consider 1 kilogram, 1 kilogram substance, 1 kilogram substance. Hurry. Now, how we can explain specific latent heat for melting? Melting. This is a story, very simple. Now you already know latent heat and specific everything you know. එහෙනම් මෙහෙම පුළුවන්. Specific latent heat. Now if you got 1 kilogram of 1 kilogram unit mass of solid substance, 1 kilogram of solid at melting point. Melting point. Melting point mean if it is ice, it is 0 Celsius. Because melting point, 1 kilogram of solid substance at melting point, completely convert into, understand the story, completely convert into 1 kilogram. Mass no change, 1 kilogram of liquids, 1 kilogram of liquids, 1 kilogram of liquid, same temperature, melting point again, melting point, right? This is a story. In this changing process, the amount of heat absorbed, amount of heat absorbed, we called as the specific latent heat of melting. Specific latent heat of melting. Okay, that's the story. That's the story. Hurry. Write down the topic specific latent heat, capital L within bracket capital L, and write down the first one, melting, melting, and write down the definition like this. මෙහෙම ලියන්න. Write down the amount of heat requirement, the amount of heat requirement, the amount of heat requirement of, the amount of heat requirement of unit mass of the amount of heat requirement of unit mass of solid substance, solid substance at melting point, melting point. These definitions asking, therefore try to get this full story. The amount of heat requirement of unit mass of solid substances at melting point. Again, right? To completely convert into, to completely convert into, to completely convert into liquid state, liquid state, to completely convert into liquid state, without any temperature difference is called as the specific latent heat of melting. Completely convert into liquid state without any temperature difference is called as the specific latent heat of melting. Specific latent heat of melting. The amount of heat requirement, the amount of heat requirement of unit mass of solid substance at melting point to completely convert into liquid state without any temperature difference is called as the specific latent heat of melting. හරි. දැන් බලන්න මේකමද මේ කියන්නේ කියලා. විහඟ 1 unit mass of solid substance at melting point completely convert into liquid state without any temperature difference. The amount of heat requirement is the specific latent heat of melting. I got Nabil? Okay. හරි. මේකත් draw කරගන්න යට. This may specific latent heat definition එක අහලා තියෙන exam එකේ. For essay question as first part, as I remember 2019 or 21 check past papers. Okay, we can discuss all heat past papers in Saturday class after this lesson. Okay, next one, vaporization. 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 Second one, vaporization. 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 Specific latent heat of vaporization, right? The amount of heat requirement, the same thing, remember, the same thing. If I got 1 kilogram of, that means unit mass of liquid, unit mass of liquid at boiling point now, not melting point, boiling point, boiling point, boiling point, right? Unit mass of liquid substance, that means become water 1 kilogram at boiling point 100 Celsius. It's converted into 1 kilogram of gas state, same temperature, boiling point. The amount of heat requirement is the specific latent heat of vaporization. Hari, मैं මේකම change කරනවා. The amount of heat requirement of, hari, අපි ලියමු definition එක. The amount of heat requirement of unit mass of liquid substance, එච්චරයි වෙනස් වෙන්නේ, liquid substance, unit mass of liquid substance at boiling point, boiling point. to completely convert into gas state, without any temperature change. Gas state without any temperature change or temperature difference, without any temperature difference, is called as the specific latent heat of vaporization. Is called as the specific latent heat of vaporization. Specific latent heat of vaporization. Okay. After that, note down this short. Yes, you may. It is a constant that's depend on the material type. Yes, like specific heat capacity. Like specific heat capacity, that one also constant depend on the material type. Depends on the material type. Yeah, good point. Hurry. Now, now the lesson is done. Theory is done. Now we have two equations to calculate quantity of heat. No, Q equal mc theta and Q equal c theta. Now, according to specific latent heat, we can get another equation, Q equal ml now. Q equal ml. This is our new equation. Now you have three equations to calculate the quantity of heat. Q equal mc theta, Q equal c theta, and Q equal ml. Q equal ml. What's the meaning of Q? Quantity of heat. That means absorb or release heat. M mean mass. L mean specific latent heat of any physical state change, melting or vaporization, freezing, whatever, right? Specific latent heat is L. R. Note down and highlight this equation. Specific latent heat Q equal ml. Q equal ml. Q equal ml. Now get the unit of L. L unit. Other than L unit, that means specific latent heat unit. Unit of specific latent heat. What's the unit? What's the unit of L? Vihanga? Unit of L, the specific latent heat unit. Met me? You can use equation. You met L unit Q divided by M. Yeah. Q mean amount of heat, joules, divided by kilogram. Then the unit is joules per kilogram. This is the unit. Joules per kg, joules per kilogram, joules per kilogram, joules per kilogram, joules per kilogram, joules per kilogram. Hari. Now the lesson is done, right? We have calculations now. So, on this one. Yeah. Yeah, first two questions we already discussed. Give me a second. I think we have another page. Yeah, we have another. Yeah, this one. Only first one we discussed, right? I'll send this. Make a paper. If you want, you can get a printout. Only two papers, two pages. Okay, let's do question number two. Question number two from heat first part. Specific heat capacity and heat capacity. An aluminium container of mass 0.4 kilogram contains 0.2 kilogram of water at 80 Celsius. Find the heat that must be removed from the water to cool up to 40 Celsius. The specific heat capacity of water is given 4200 and aluminium is given 900 J kg minus K minus 1. Hadu? Now it's an aluminium container. Mass 0.4 kilo. 0.4 kilogram mass. Aluminium. 0.2 kilogram of water. 0.2 kilogram. That means 200 kilogram of water. Both system at 80 Celsius, right? 80 Celsius system convert into 40 Celsius. That means heat releasing, heat energy releasing, exothermic, right? The specific heat capacity of water and aluminium given. They came a specific heat capacity is given, right? Then MC theta for both. For water specific heat capacity, water 4200 J kg minus 1 K minus 1. For aluminium, specific heat capacity of aluminium 900 J kg minus 1 K minus 1. Then what is the method? Quantity of heat equal water release heat plus container release heat. Water release heat. Now heat releasing, no? Water release heat plus container release heat. Water release heat plus container release heat. Water release heat mean MC theta because specific heat capacity is given. Container release heat MC theta, same. Now it is CW, C aluminium, right? That's only difference. A more, but you can mention if you want. Now 0.2 kilogram of water, 4200. Temperature difference 40, no need minus 40, right? Temperature difference mean only higher value minus lower value, right? 80 minus 40 plus 0.4 into 900 into 900 into 40. Same temperature difference. Hurry, get the value. Very simple calculation. Okay, the third one is the main calculation from specific latent heat. Mame. This question from basic part, previous part. Finger, what's the answer? 0.2 into 4200 into 40. $33,600 for this part or total ne? First part, okay. First part 33,600 joules plus 14,400. Then total 48,000. 48,000 joules. That means 48 kilojoule. 48 kilojoule. Okay, that's from specific heat capacity. Always remember, if you use heat capacity or specific heat capacity, it should have a temperature difference. It should have a temperature difference, right? If there is no any temperature difference it's a physical state change. Then you have to use ML. That's the rule. You have three equations. Remember, you have three equations. Q equal mc theta, Q equal mc theta, Q equal c theta, and Q equal ml. If there is no any physical state change, it has a physical temperature difference. Physical state change it has a temperature difference, right? There is a temperature difference like this. Now 80 Celsius water up to 40 Celsius water, no any temperature, no any physical state change. Therefore, they don't have physical state change, right? Physical state change therefore it has a temperature difference. For these cases, you can use both mc theta and c theta according to our requirement. අපි දන්න value එක අනුව, if it is no specific heat capacity, you can use mc theta. If you know heat capacity, you can use c theta. But if there is no any temperature difference එකක් නැත්නම්, it has a physical state change, you have to use ml equation. That's the rule. හරි. අපි බලමු question number 3. A beaker contains water at temperature of 100 Celsius. If it is specific latent heat of vaporization 2.2 into 10 to the power minus 6 joules per kilogram, find the heat requirement to completely vaporize 20 gram of water. Completely vaporize means convert into 100 Celsius vapor. Okay, 100 Celsius vapor. The question asks the required heat amount only for this vaporization. The container absorb also getting some heat amount. Absorb karna heat එකක්. දැන් මේක ඒකනේ වෙන්නේ. The amount of heat requirement to vaporize 20 gram of water from this beaker. Now, see, now 100 Celsius water, 20 gram, right? I want to convert into 100 Celsius vapor. That's a vaporization. Completely vaporize karna can make, right? 20 gram. Now you can see there is no any temperature difference. If there is no any temperature difference, it is a physical state change. Actually, it is vaporization. Now you can use Q equal M L only. Temperature difference එකක් නැත්නම් තමයි මේක දාන්නේ. Q equal ml, right? The mass 20 gram, 20 divided by 1000 to convert it to kilogram. Specific latent heat given. Specific latent heat of vaporization. Vaporization එකේ දීලා තියෙනවා. Now it is vaporizing 2.2 into 10 to the power minus 6. 10 to the power minus 6 J kg minus 1. Now kg minus 1 to kilogram cancel out. Now 0 cancel out. It's a very, very small value, 0.02 into 2.2 into 10 to the power minus 6 joules. 0.02 into 2.2. 0.044 into 10 to the power minus 6 joules, correct? Yeah, that's a very, very small value required. Então, මෙහෙමත් පුළුවන් 4.4 into 10 to the power minus 8. That also okay. 4.4 into 10 to the power minus 8. Okay, however. Okay, let's go to next question. They are simple questions. Fourth one, a beaker contains ice at 0 Celsius. If the specific heat if the specific latent heat of ice of melting 3.6 into 10 to the power 5 joules per kilogram. Find the heat required to melt 50 gram of ice in the beaker. Melt only 50 gram of beaker. Calculate. Okay, what's the value? Question number 4. 50 gram of ice convert into 0 Celsius ice to now it is in melting point. Completely convert into water state, liquid state. Quickly calculate and send this answer. Okay, what's the value? Now it is 50 gram of ice at 0 Celsius convert into 0 Celsius water. Now it is melting, no? The heat amount is asking. Q equal ml only. 50 divided by 1000 convert into kilogram. The specific latent heat is given 3.6 into 10 to the power 10 to the power 5, not minus 5, j kg minus 1. Kilogram to kilogram minus 1 cancel out. 0 to 0 cancel. 5 into 3. Yeah, 5 into 3.6. 18, no? Not 80. Yeah, 80. 18 divided by 100. 0.18. 18,000 joules. That means 18 kilojoule. 18 kilojoule required. 18 kilojoule. Yes, this is correct. 18 kilojoule or 18,000 joules. Hurry. Okay. Now the most important one. 5 kilogram of water contains in a container at 20 Celsius. If this water amount completely vaporize at the boiling point of water, boiling point of water 100 Celsius. Calculate the water absorb heat for this process. Water absorb heat, right? Contain absorb heat නෙමෙයි water absorb heat. Specific heat capacity of water 4200. Specific latent heat of vaporization 2.2 into, I think it has mistake. Actual value එක බලන්න search කරන්න specific latent heat of vaporization in water. No? Sorry, it is not minus 6. It is plus 6. එක තමයි මම බැලුවේ. කලින් එකෙත් no problem. කලින් එකෙත් එන්න ඕනේ plus 6 then. No problem, no problem. Fifth one, it is plus 6. Plus 6. 2.2 into 10 to the power 6 joules per kilogram. Now correct. Alright, I'll give you 2 minutes. Now you have to careful starting from 20 Celsius. Then it is completely vaporized. Alright, get 2 minutes. Okay. Now it's a special one. Now 5 kilogram of water, 20 Celsius. Neighbor. Question number 5. Question number 5. Now it is initially 20 Celsius water. 20 Celsius water, 5 kilogram. Right? First it is converted into 100 Celsius water. Because that is a boiling point, right? That's a boiling point. 100 Celsius water. 100 Celsius water. Now, at the boiling point, 100 Celsius water converted into water vapor, completely vaporized. 100 Celsius water, 100 Celsius vapor. That's a vaporization. Right? Now I told to calculate quantity of heat, we have two steps. With two equations, right? 20 Celsius water up to 100 Celsius. Mass how about 5 kilogram? No? 5 kilogram. Then there is a temperature difference. That means no physical state change. 20 Celsius to 100 Celsius. Water. They come water PM. Then no physical state change. Then MC theta. Specific heat capacity is given. But 100 Celsius water, 100 Celsius vapor, no physical, no temperature difference. That means there is a physical state change. That's a vaporization. In ml. Hari. Make a thermal. Nabil. How to use these equations? Yeah. Now you can substitute values into this equation. Make it a values ටික දාන්න තියෙන්නේ. ඉතින් M5 kilogram. Water specific heat capacity 4200. J kg minus 1. K minus 1. Temperature difference 20 to 100. 80. 80 I told difference you can use, substitute in Kelvin, no problem. M5 kilogram. Specific latent heat at vaporization 2.2 into 10 to the power 6, 10 to the power 6 jk minus 1, jkg minus 1. Now kg minus 1 to kg cancel out. Hurry. Get the value 5 into 4200 into 80. Joules plus 5 into 2.2 11. 5 into 2.2 mean 11. Up make a value 1, 2, 3, 4, 5, 6. Then what is the value? Yeah. Then 11, 1, 2, 3, 4, 5, 6 plus 16, 80, 3 zeros. No, a small mistake, I think. Have you got 14,000? No, 12,680 නෙවෙයිද? 3 zeros joules, then 12,680 kilojoule. Yeah, met me. Take again. Now it is 5 into 2.2, 11. 10 to the power 6 means 6 zeros. Yeah. Use calculator. Calculator එකේ කෙලින්ම type කරා. Then easy. Fifth one, okay. A copper calorimeter mass 0.1 kilogram contains 0.2 kilogram of water at 80 Celsius. The specific heat capacity of copper and water are given respectively. If the specific latent heat of vaporization is given, find the heat required to vaporize all the water in container. Before question, 10 to the power minus 1 are those first value. What? Before question mean fifth one? Latent heat values are මෙතන දහන්න. මේක. Third one. මේකද? Yeah. Make it actual value should be plus, but you have to substitute the question given value. අපි internet එකේ search කරාම the specific latent heat, this specific latent heat value is given in Excel. මේ question එකේ දෙන value එක තමයි දාන්න ඕනේ. Actual value is 2.26 into 10 to the power minus 10 to the power plus 6. Sorry, that's no issue. You don't need to remember these values, they are giving. Here they know. Okay, let's do question number 6. A copper calorimeter mass 0.1 kilogram contains 0.2 kilogram of water at 80 Celsius. The specific heat capacity of copper and water are 400 and copper 400, water 4200. If the specific latent heat of vaporization amiyat plus 6 plus 6, 2.2 into 10 to the power 6 joules per kilogram. Find the heat required to vaporize all the water in container. To vaporize all the water, the heat requirement is asking. The heat requirement is asking for the container. Water in a container. Container එකට දෙන්න ඕන heat එක අහන්න. Right? Then මේ වගේ. Question number 6. Question number 6. Now these are maximum. Then මේ වගේ එකක් තමයි එන්න පුළුවන් maximum question. Now this part. Now this is a container. How about mass? 0.1 kilogram. m equals 0.1 kilogram. 0.2 kilogram of water. 0.2 kilogram of water. Both 80 Celsius initially. 80 Celsius. If the specific heat capacity, yeah, copper specific heat capacity here 400 J kg minus 1 K minus 1. Water specific heat capacity CW 4200, it is same, J kg minus 1 K minus 1. Water specific latent heat at vaporization, it is given 2.2 into 10 to the power 6 J kg minus 1. Right. They are the data given in the question. Find the heat required to vaporize all. Heat requirement. The Q is asking to vaporize all water. Hari, Hadu. To vaporize all water. That means 0.2 kilogram. Okay, first what happened? Then make it has three equations use කරන්න වෙනවා. කොහොමද? How to use? Now Q equal water absorb heat plus container absorb heat. Water absorb heat and container absorb heat. Okay, මේ බලන්න. Water absorb heat. First 80 Celsius water. 80 Celsius water convert into 100 Celsius water. 100 Celsius water. Increase the temperature up to boiling point. Then 100 Celsius water vaporizing. 100 Celsius vapor. It is for water, right? Make it advent only. Container 80 Celsius to 100 Celsius. Is there any physical state change for container? Can container එක melt වෙනවද 100 වලදී? No. Container is a solid. Container boiling point, that means copper boiling point, it's a large value. 100 Celsius, not copper melting, right? Only water. Then temperature difference mc theta. Physical state change ml. Temperature difference of container mc theta gain. Hari, මේක තේරෙනවද? Could you get this? Understand? Hari, මේක දාගත්ත කියන්නේ the calculation is then only substitute values. It's easy. Nabil, Q&A. දුලෙන් හරි දැන් තියෙන්නේ just substitute values 0.2 kilogram of water 4200 is the specific heat capacity මෙහෙට ගන්න 0.2 kilogram 4200 is the specific heat capacity temperature difference 80 to 100 80 to 120 plus 0.2 kilogram of water specific latent heat 2.2 into 10 to the power 6 plus mass of container 0.1 kilogram specific heat capacity of copper 400 temperature difference 80 to 120 හරි ඔච්චරයි now you can get the value 16,800 0.2 into 2.2 44 1234 plus 0.1 into 400 into 20 800 all are joules right all are joules හරි then you can get the total මම මෙතනින් දාන්න total what's the value correct විහඟ correct okay හරි now question number 7 for homework question number 7 homework okay you don't need thermal curve still you don't know thermal curve is our next topic thermal curve ඕනේ make කරන්න second one the heat required 20 gram of water. Yeah, that's mixture method. Yeah, are they all questions from mixture method? Our next, we have another two topics of this part. Yeah, I'll send this document into group. Question number 7 only homework. 7 only homework. We have two another method topics of this part. Quantity of heat part. We have two another topics. Thermal curves and mixture method. Thermal curves and mixture method. Hurry. Now 11:15. No? Okay, let's. Okay, write down the topic. Api next day karamu. Thermal curve is the next topic. Thermal curves. Thermal curves. Thermal curves. Thermal curve. Thermal curve. Thermal curve. Okay, today we did very important and special topic. The specific latent heat. Specific latent heat. What's the meaning of specific latent heat? The amount of heat absorbed or released during a physical state change of unit mass of substance. Right? That's a specific latent heat. Are they asking always until the all water vaporized normal? No, it's not always. දැන් අපි මේ question එක අහලා තියෙන්නේ කොහොමද? Question number 7. Now it's a long journey. 100 gram of ice cube at minus 10 Celsius. Right? Ice cube at minus 10 Celsius completely convert into 110 water vapor. It's a long journey, right? Minus 10 among minus 10 first convert into minus 10 ice convert into 0 Celsius water, right? Sorry, 0 Celsius ice. 0 Celsius ice. Now 0 Celsius ice, 0 Celsius water. That's a melting. Now 0 Celsius water, 0 Celsius, sorry, 100 Celsius water. That's the temperature increase up to boiling point. Then 100 Celsius vapor. Again 110 Celsius vapor. It's a long journey. Like a local calculation. Understood? Okay, that's a path. They're not always asking until the all water vaporize. No. But you have to calculate according to the given question. Question එක දීලා තියෙන විදිහට හදන්න. Okay. Okay. Any doubt? Today we did very advanced part actually. Okay. Before next week, again go through this theory and revise 3 to 4 times again. Then easily you can remember this story. Any doubt? So what is the difference of all water vaporization and just vaporization? No, all water vaporization කොහෙද තිබ්බේ? Yeah, if it is vaporize all water mean you have to get the full mass. ඒ කියන්නේ දැන් මේකේ තියෙන්නේ copper calorimeter mass 0.1 kilogram contains 0.2 kilogram of water. Then if it is all vaporized, you have to get 0.2 kilogram mass එකට ගන්න ඕන. You have to get total mass as the vaporized amount, ml වලට. But in previous questions, it has a 20 Celsius water in a container, but only vaporized. Make it next previous one. Only vaporized 50 grams. Then 50 grams tama ගන්න ඕන. Understood? Okay. If it is completely vaporized, එතකොට ගන්න ඕනේ for total mass. Right. හරි. I හදලා බලන්න. I'll send this paper into group. Okay, after question number 7, all questions based on mixture method. Mixture method එකෙන් තමයි තියෙන්නේ. Okay, let's do mixture method. Next day, it's a long lesson actually. Mixture method and thermal curves. Our next day lesson. Okay. Any doubt? Dinod? හරි දැන් ක්ලියර් වුණාට ආයෙම බලන්න ඕනේ මේක හරිද before next week 2 to 3 times again revise and again calculate these questions, go through these questions and revise again before next week. Hard. Okay, let's meet next Saturday evening. Goodbye.